Hey folks, so this is a talk about a deep dive into OpenSearch plugin architecture, and we'll be briefly introducing the hot reload functionality, which we are working on. I'm Pranav Garg, and with me is Aman Kumar. We are both from AWS Managed OpenSearch. So this talk is aimed towards the internals of OpenSearch and how plugins are loaded and used. But we are going to start just by dipping our toes in. We are going to look into OpenSearch plugins as a system developer or somebody who wants to just use the plugins, not bothered about the internals of OpenSearch. We'll discuss how the plugins are, what the plugins are, and how they can be used. We'll then go down a layer down as a developer who contributes to OpenSearch and look at OpenSearch from a bird's eye view. Post that, we will dive into the low-level workflow of how exactly these plugins are loaded during Node Bootstrap. Finally, Aman is going to dive into the hot reload functionality. He's going to differentiate between hot load, reload, the challenges which we are facing, the proof of concepts that we have worked on, and how we plan to extend that. Great, let's get started. So why do you even want to use plugins? Just like your coffee order, search can be something very personal. Sure, you can order something out of the set menu, but more often than not, you would have a very specific use case. It can be that you want to do a term search on English, or you want to do search something very specific. Maybe I want to analyze Japanese or Hindi. Tokenization logic for that might change. Maybe I want to do a different kind of post-processing, which is not offered by OpenSearch out of the box. Now, one way to do that is I'll just fork OpenSearch. I mean, sure, we are working with folks, and take a look into the 12 million lines of code, make changes in that, but I don't think that's a good idea. Instead of that, what else can we do? Well, lucky for us, OpenSearch provides a really good extensibility functionality via the plugin functionality. You can create plugins for nearly each and every plugin types or every services which are within OpenSearch and change the way that it works. So the plugin functionality, as we said, is quite versatile. But before we discuss much about that, let's quickly get to know how it evolved over time. As we all know, OpenSearch was forked from Elasticsearch version 7.10, and Elasticsearch was created around 2010. Even in the pre-1.x version of Elasticsearch, there were plugin services already present and signs of extensibility. Now, over time, as ES development went on, the plugin functionality was enhanced, which I think, and again, this is my personal opinion, was fueled by the development of XPack that would make Elasticsearch commercial. Since XPack fundamentally changes how the plugin, how OpenSearch would work, that would mean that Elasticsearch has to ensure plugins can be used to enhance each and every internal service. So yeah, thanks to XPack, we have a really good plugin functionality. Post that, with development of Elasticsearch versions, new interfaces were added over time, and then the fork happened after the license change. Now, OpenSearch 1.0 was nearly identical to Elasticsearch 7.10, so not a lot of development there, but with 2.x, we started to see a lot of changes. Most notable ones of them is Semver support. Now your plugins, instead of supporting just one particular OpenSearch version, can support a range of that. You have better dependency management. And I think the best part is the extensions project. So the plugins within OpenSearch, they work in the same JVM as your OpenSearch. They work in memory in the same process, which is useful in a lot of cases, but can lead to other issues such as security, stability. So for that, an idea was floated around to have out-of-box plugins running in a different machine or a different Docker container. Those were the extensions project, which was released around 2.9 and is currently It is currently an experimental feature. So we won't be discussing much about that here, but if you would like to go ahead and get extensions developed further, please feel free to contribute on the open source end. Now, what are the different plugin categories? Broadly, plugins in OpenSearch can be divided into three parts. The first one are modules. These are packaged with OpenSearch, even the minimal distribution. So these are functionalities which have been packaged and use plugin interfaces. They are loaded by plugin service during bootstrap time, but if you do a cat plugins call, you won't be seeing them. After that, you have your plugins. These are, again, just modules, but visible by plugin service. So you can simply go ahead, load whatever plugins you want to. Those are the standard plugins we'll be talking about today. And as we discussed before, last ones are out-of-process plugins, which are extensions. Cool. So let's quickly discuss plugin types. Now, last I checked, there were 27 different plugin interfaces that are present in OpenSearch. A lot of them are experimental, so if we go through that, I think we'll take around 2 hours. Are we okay with that? No? No, okay. I don't think we can take 2 hours. We'll just go through a few of those plugins. Plugin types, so we have got script plugins, which allows you to create custom scripts that can be executed whenever you want it to be, can be during indexing, can be during search. You've got mapper plugins, which allows you to create your custom mappings for your indexing. Analysis plugins, you can go ahead and define your tokenizing, filtering logic. You've got your search plugins. Maybe I want custom re-ranking. Maybe I want to search using some ML algorithm, which is not available. So you'll use that. You've got your engine plugin. You can replace the entire engine, which is working on the backend. You've got your circuit breaker plugins. Why I've mentioned it, I'm mentioning it over here. We'll get to know it later. But circuit breaker plugins change the circuit breaking logic to ensure that your cluster is stable. And find your action plugins. If you want to introduce a new API endpoint, go ahead and create an action plugin. Cool. So how do you use these plugins in OpenSearch? Now, what OpenSearch does is that it provides an abstract plugin class that you extend. In addition to that, for all of these plugin types, they provide interfaces, which are contracts pertaining to the particular use cases. So you can implement one or more interfaces, just as we saw in the previous talk. Now, here's some shameless promotion, but this is a sample plugin repository. So it was an example. I had an idea one day that why don't I create a plugin, an analysis plugin that uses a LLM to tokenize my inputs. In that case, it would become like a universal analyzer. I'll say that, hey, I want transliteration. It will give me that. I say I want sentiment analysis. It will give me those sentiment tokens. So for that, I had 2 requirements. Why don't I go ahead and create an action endpoint, which I can use to configure my tokenizers, and then analysis endpoint, which is going to give me those actual tokens. Once I did that, the plugin was ready. As I said, it's a shameless plug, so if you guys are interested in taking this further, please feel free to contribute. But if you want an in-depth session on how to create one plugin, we are lucky. We had a really good session right before us, and we have another session tomorrow, which is CYOP, Create Your Own Plugin. It's a talk/informal workshop by my amazing colleagues sitting over here in the gold room here tomorrow at 9:40 a.m. OK, now you have your plugin ready. What does your plugin look like now? So your plugin would most probably be a zip file. When you open up, it's at least going to have the 2 out of 3 things over here. It will have your plugin jar files. It's going to have a plugin descriptor properties file. And it's going to have a plugin security policy file. Now, the plugin descriptor properties file is a bit important. It tells your plugin service what exactly it is looking at. What happens afterwards, we'll get to that. But yeah, the important things here are the class name. You'll see what class name implements these interfaces, which we had just discussed. The OpenSearch version, here we have just defined 2.17, but you can have it in a range. You can say that my plugin works with 2.x, so it would load with all of them. Extended plugins. Let's say my plugin is dependent on security plugin during runtime, or maybe compile time as well, but that's a different story. Then different story. We'll get back to that in a while. Now, you have your plugin ready. How will you use it with your OpenSearch cluster? See, using plugin, you will use something called as the plugin CLI, which is provided by OpenSearch. The plugin CLI is not going to do a lot. It's going to take a look at your plugin structure, do some validations, and just copy it in the plugins folder. But your plugin is not installed. You have to make a sacrifice over here. You have to take your running cluster and then bounce it again. All the traffic you have is going to go away. Or you can do what we do on the managed service end and just do a blue-green deployment, have a new set of domains with the plugin already present. So let's do a quick dive into OpenSearch. I'm going to go to condensed diagram in a moment, but before that, if you want a detailed diagram, you can quickly scan it. We'll take 5 seconds for that. Yeah, so this is a detailed SVG diagram. You can have a look. 5, 4, 3, 2, 1. We good? Anyone? Good. All right, so here we have the condensed diagram of what OpenSearch is. And as you can see, it's vast. I had to condense it, and it's still this. It's a service made out of many small modules. Again, this is a model. All models are wrong, but some models are useful. So the way we modeled it is we decided to layer it based on the order where they are booted, and how the bottommost layer depend on the layers that come before that. So as you can see, at the very top over here, we have the node layer or the node class. This is the central coordinator that manages all the service life cycles. It is the orchestrator that handles dependency injection via juice, and it controls the startup shutdown sequences. It provides a universal service access point. Of course, that's the most fundamental system, the node, right? Post that, you have the foundation layer. This essentially keeps your node alive. These are the services that manages your node and keeps it safe. Well, at least they try to keep it safe, but if you are running a crazy workload, it might go it might go crazy. So it has basic infrastructure services, no business logic dependencies over here. It provides you with core system resources. You've got threads, you've got system environment, you have got node environments, you have got your circuit breaking service, which ensures that if in case of any high CPU intensive jobs, it simply goes ahead and kills the process. Great. Up next, we have the tier 2 layer, which we just a second. Yeah, tier 2 layer, which is the core infrastructure layer. Again, no business logic over here, and it is dependent on the foundation layer. This introduces your distributed system functionality, because when you're working with OpenSearch, I hope you're not working with a single node. You should be working with multiple nodes. It implements the cluster coordination and internode communication, indice management, shard management, data distribution, and a standout over here is plugin service. Why? We'll get to that in a minute. Finally, your specialized service layer, which has your business logic. It depends on the layer before that. You do your query processing, your search execution, data ingestion, snapshotting, system monitoring, cluster discovery, and operational management. Great. So we have all of these, and we have plugin service as part of the layer which we discussed right before. But plugin service is something that works with all of these services. Not directly, but a bit indirectly. What exactly does the plugin service do? How does it load plugins? So the loading of plugin happens when Node bootstraps. As soon as Node starts to bootstrap, one of the first services it starts is the plugin service. Once plugin service is started, it scans the modules and the plugin directory folders. Post that, you remember the descriptor files which we saw, right? It reads those descriptor files and validates that everything is fine. For example, it says that, hey, you just said you're a plugin for OpenSearch 2.17, but we are running on 2.19. I won't allow you to go further. If it sees that you're extending another plugin, it does some sort of topological sorting and ensures that the plugin which came in before gets loaded before your plugin does within the same class loader. Once that happens, it resolves all the dependencies, creates isolated class loaders for different plugins, and it instantiates those plugins. Once it's done, your plugin service is initialized. Your plugins are loaded within plugin service. It returns the callback to your node service or your central node. Post that, if any of your plugins have some custom settings, those settings would be added to the environment settings for the entire cluster. So after this, your OpenSearch.properties file is read. And let's say you have a setting which is specific to a plugin, for example, KNN. It would be able to read that. If not, you're going to get an exception, and your node won't boot up. Now is the most important time. All of the other services which we saw over there, they are initialized after this. So what happens is that node service asks plugin service, hey, I am about to initialize analysis registry, which is for analysis. Can you give me all the plugins that implement the analysis interface? So plugin service is going to return back a list of those particular plugins, which would be used within the constructor of these different services. Now those services, they then talk to the plugin service and get the plugin classes, put them in memory, put them within the process. So it is loaded as if it's part of the core OpenSearch itself. OpenSearch does not differentiate between your plugins and between the code which has been introduced by itself. Finally, everything is wired and your OpenSearch is up. So just to quickly summarize, your plugin service, it discovers your plugins, scans them, validates them, does your dependency management, ensures that the plugins are isolated with each other via class loader. If there are multiple plugins and OpenSearch having conflicting dependencies, then it ensures that does not happen. Handles the plugin lifecycle, integrate it with other OpenSearch services. And after all of this happens during Bootstrap, the high and mighty plugin service simply becomes an informational service. You just ask, hey, what plugins are loaded? It's going to return them back. Well, but there's an issue. All of this, it happens during Bootstrap. Once Bootstrap is done, you cannot load any more plugins. And how can you? There are a lot of issues around this. Because since all the services are loading plugins when the constructor is called, there are no hooks or endpoints to do it while the services are running. That can lead to system inconsistencies. In addition to that, plugin service also needs to be omnipotent, where you will be able to call the service and quickly load some plugins. The more we dive into it, the more it seems like each plugin type would be a different project altogether. Feels like an impossible task. But as my mentor once said that you're an engineer, it's your task to figure out the impossible. So that's what we are trying to work on. And for such an impossible task, such a Herculean task, we need to have a damn good engineer. So I think Aman is the one who took up the challenge. So please welcome my amazing colleague. He's going to take us further on how we would be hot reloading the plugins.
Yeah. Thank you, Pranav. OK, thanks, Pranav, for the nice dive deep onto the plugin service architecture. Now, moving on, we will be discussing about the plugin hot reloading. As Pranav mentioned before, the plugin installation today requires OpenSearch process to restart, right? And due to this requirement, plugin installation adds to the operational overhead on self-managed clusters. And at the same time, if you are using the managed OpenSearch cluster, then a blue-green deployment is required to install the plugins, and which is, again, a time-consuming process. While this blue-green deployment ensures zero downtime, it leads to more resource consumption and operational challenges. So basically, with plugin hot reloading, we are aiming towards installing and updating a plugin at run times. That means OpenSearch. I mean, we should not need to restart OpenSearch process after a plugin for plugin installation. Okay. Apart from that, OpenSearch provides some APIs and some features that might be confusing with this hot reloading functionality. For example, I think we have briefly discussed it before, like OpenSearch provides an install API. This API essentially copies your plugin zip from the source directory that you have specified into the OpenSearch plugins directory where all the plugins gets installed. Okay, like calling this API does not mean that your plugin has been installed and is available for use. You still need to restart the OpenSearch process. Next is reloadable plugins. So this is an interface which is like extended by multiple plugin types. For example, repository plugins. However, this interface also like lets you update some configurations or settings of like already installed plugins. It does not allow you to update the components of the plugin or maybe install a fresh plugin altogether. Cool. Okay, so we have a few goals with this plugin hot reload functionality. The primary functional goal would be to have the ability to basically install, update, and remove plugins without process restart. And then, while we are doing this, we should definitely not impact our ongoing traffic, right? And also, there should be no performance impact on any search or indexing or any other requests that are going on our cluster, right? Further, we want to maintain consistency while creating, updating, or deleting index data using plugins. So let's say, for example, I have installed a plugin and I have a multi-node cluster setup, and the plugin got installed on like 80% of the nodes, but on 20% of the nodes it got failed, right? So definitely, I would not want to like create an index which is using that plugin and it is not available on some of the nodes, right? That would be kind of an inconsistent behavior. So yeah, and the second thing, the last thing that we are targeting with this is the ease of plugin management. So basically, like storing all plugins information at some place and then using some APIs, metadata APIs to like refer those information. Cool. A quick recap of plugin loading mechanism. Typically, there are two phases to plugin installation. One is plugin loading. This basically means adding the plugin classes to the OpenSearch JVM. And currently, this happens during node bootstrap only. And further, this process is like common for all the plugins, right? Then we have plugin registration, where different plugin types have their own different registration mechanisms. For example, like analysis plugin components, like char filters, tokenizers, or maybe token filters, etc., are added to the analysis registry. Similarly, for search plugin components are added to named writable registry and named X content registry. So, there are a few plugins that we have gone through. We have read about their like dive deep into their registration process. But definitely, different plugin types would have different registration mechanisms. They might be registering some handlers. They might be registering to adding their components to some registries, like these ones. Okay, so in the past few months, we did a POC for hot loading of a plugin, and we used analysis plugin. So for the next few slides, I'll be referencing the analysis plugin terminologies a bit more. Okay. So this is like a condensed diagram of what Pranav did mention before. Like starting with node.java, which instantiates the plugin service class. And from once this plugin service class is instantiated, it loads the bundle, which is basically your zip files, and then creates your class loader, and further loads the plugin classes into the OpenSearch JVM, and instantiate the plugin. After that, your node asks for like filtered plugins. For example, in this case, it could be like analysis plugin types, right? And yeah, and then we instantiate like analysis module, which further creates your analysis registry, where all the analysis component, all the analysis plugins will be like information would be stored. And before that, we'll extract the components of the analysis plugin. Could be like multiple, but let's say in this example we are showing like tokenizers, token filters, care filters, etc. So all of these components are then stored in this analysis registry, which is a map of your components, map to the implementation, like factories or their classes, corresponding factories and classes. Yeah. Okay. Cool. With this architecture, we have certain limitations. So the analysis registry that we just saw, right, where we are storing this component, where we are storing the mapping of these components to their implementations, these are currently immutable. So that's the first reason I would say why we are not able to like load a plugin at runtime, right? Because and all of these registries are created at the node bootstrap only, right? And once your open source process has started, they become immutable, and you cannot add anything else further later on, even if you are able to load the plugin. Then there is plugin registries. These plugin registries or the methods basically to extract the, to load the plugin or to like load the classes into JVM or like extracting out the components of a plugin. These are all called during the corresponding class constructors. And then at last, so updating factories or classes references by reloading the plugin. So this means, let's say I have a plugin already installed on my OpenSearch cluster, and I want to update the implementation of, let's say, one of the components, right? But let's say after, I mean, even if I installed that plugin, I should be able to see that implementation, the change that I have updated, right? That should be that I should be able to see in like in effect, right? So, however, let's say some service, for example, for this analysis plugins, let's say some service indexing services using these analyzer plugins, we'll have to update the reference to the indexing service as well. That the plugin has updated now, the plugin has changed now, and we need to pick up the latest implementation. So yeah, that again pose a different difficulty there. Okay. Okay, so we made some updates to make these plugins hot reloadable. We added actually 3 APIs. The plugin load API to load the basically plugin classes into the OpenSearch JVM process, and then the register API, which will basically extract out the components and you put it into the analysis registry for these, and then the remove API to like remove all these components from whenever a customer wants to like uninstall a plugin, or so we'll remove these components from the analysis registry. However, this is like the customer-facing part or the API part. I would say the most, I mean, the changes were more involved in the core of it. Like we had to update plugin service class to load the plugins on the dynamically, basically. And then we had to update the analysis registry, immutable maps to concurrent hash maps, so that we would be able to add those components at runtime once a plugin is loaded, right? And then further, we had to update like corresponding classes for like analysis module and analysis registry to basically support this dynamic loading of the plugin at runtime. Then at last, we had made a change in plugins info data structure. Basically, this plugin info is the one that stores the information about your plugins, and cat plugins also refer this data structure. So we also made this as well dynamically. I mean, we made this data structure as dynamic, and so yeah, we post calling this plugin register API, we were able to see that information that a new plugin is installed via cat plugins itself. Okay, cool. Next, enhancements to current architecture to support hot reload. So most of the points are like similar that we discussed in the previous slide. For example, making these data structures or the registries immutable to mutable, so that we should be able to add components on them, and then we'll have to based on the different plugin types, we'll have to update the corresponding implementations to make them dynamically reloadable. Another thing that we can add is a plugin data structure. This could be a simple system index that will store information all plugin related information. For example, the plugin components, all the indices that are using these plugin components, and the nodes on which a particular plugin is installed. So this information would be useful for customers, as well as we can use this internally where the other services, for example, indexing service or maybe any other service which is using our plugin, would be able to get the plugin state from this data structure. Okay. So yeah, post that POC, we did feasibility analysis of different plugin types for their suitability to hot reload. And we broadly categorize them into two categories. The first one is stateless plugins. These plugins generally do not maintain any internal states. They run independently, and also other services do not depend on these plugin types. The second one is stateful plugins, where they maintain some certain internal states, and other services, like for example indexing service, they depend on these on the state of these plugins, right? So these stateful plugins are a bit difficult to hot reload because again we'll have to update once a plugin is updated, right? After reloading, once a plugin is updated, then we'll have to update the reference of the consumer service as well, right? So that they would be able to see the change. Then further, given multiple other factors, for example, thread safety and how a plugin type interacts with the core OpenSearch, how do they interact with the different other services, OpenSearch services, right? So we have categorized them into 3 more categories, which is highly feasible, moderately, and low feasibility to hot reload functionality. I won't be going into details of each of the plugins, but let's say, for example, if you take a network plugin. So network plugins are generally involved in the cluster formation, right? Node-to-node communications and all those. So, so this type of plugins pose difficulty if, hot reloading, because we might run into the issues where cluster, node gets dropped or cluster is broken. So. Cool. And yeah, currently this functionality is in development, and we'll be putting out an RFC soon. So please keep a watch out for that. Then further, we are planning to implement this in phases. The first phase would be to lay the foundation, where we will be loading plugins at changing the plugin service class to load plugins at runtime, and then adding some metadata store, some metadata APIs to get that information. Then the phase 2 would be to explore and implement the hot reloadable functionality for some feasible plugin types. And then the phase 3 would be to extend the reload functionality to all the plugin types which are possible. Yeah. Thank you. We are open for the questions.
Thanks, folks. Any questions? If not, we are always available. Yeah.
I guess the framework that you're working with, you still have a dependency where the plugin versions have maximum versions.
So with the current Semver functionality, we kind of relaxed that a bit. You can go for a major version match, and that should work. We do have that dependency, but let's say you have got 2 different binaries of a particular plugin. You have a binary which is already loaded, and you want to make some changes to that. Maybe you're doing some A/B testing with a search plugin. If you want to make the changes, you can simply just replace that with the new plugin. Sure, we will be looking at the plugin descriptor properties. That needs to be done, but you can keep the same OpenSearch version there. So that shouldn't be an issue. But yeah, with the Semver functionality, let's say you're going from 2.17 to 2.19, you don't need to change the plugin type. And that functionality already, you don't need to change the plugin binary. if the existing binary has a semver range mentioned. So that functionality is already present, can be used right away. Yes, please.
So hot reloading in a JVM context has been around for a while, like frameworks like OSGI. Would you look at that for any inspiration, or would that have been too disruptive for plugin providers to move to a new framework as a standard?
Well, over here, the challenge is, I would say, is a bit different. The challenge is actually updating the existing services, and ensuring that ensuring if these are stateful services, that the state is compatible with the new service. So we are looking into a bit of sandboxing to be done when the plugin is being reloaded. Another issue which we foresee is the switching, the point when we are switching. Any calls made during that time or any operations done can take the cluster into a bad state. So I would say these are comparing apples to oranges. Yep. Anything else, folks?
Is there any protection of the memory space? Like you're developing a plugin, you're dynamically loading it, you unload it, bring it back up. I mean, are you doing anything to clean up the memory space that the previous version of the plugin may have left around?
Yeah, so that is something which we are looking into because we did take the heap dump of the analysis plugin that we had hot reloaded, and we saw that the older plugin was not present anymore. We need to do that for each plugin type. As we mentioned, all the 27 plugin types have different ways of getting loaded. So these are 27 different sub-projects. So that is one thing which we are ensuring while working on this, because we don't want any memory leaks happening while we are doing the hot reload process.
And also, during our first phase, we'll be considering all these things. It would be like setting a foundation for this hot reload functionality. So yeah.
Anyone else, folks? If not, we can conclude. All right, then. Thanks a lot. Have a great day. We'll see you.